Hey everyone, we are on the absolute verge of a massive shift in how we build the very foundations of our digital world. Today, we're going to simply explain a radically new approach to semiconductor design and manufacture. It's an incredible story about human ingenuity, hitting the hard walls of physics, and ultimately inventing a completely new way to measure progress. Let's dive right into this explainer.
Now, to really wrap our heads around this, I want you to imagine the microscopic world of computer chips as this vast, bustling metropolis. For decades, the leaders of this city measured their success by how tightly they could pack the buildings together. Smaller blocks meant more processing power, lower costs, and faster growth. But what happens when that city finally reaches its absolute physical limits and literally cannot squeeze its buildings any closer together?
Well, for over 50 years, Moore's Law was basically our trusty map, demanding we constantly shrink the physical space of transistors. But recently, Huawei proposed a bold new map called the Tau scaling law. Instead of fighting a losing battle against spatial geometry, this new paradigm shifts our focus entirely to shrinking something else: time.
Let's lay some groundwork here with what we like to call Papa's take. As Papa Q-Bear, that's Papa's father, always used to say when we were working in his crowded garage, if you can't make the workbench any smaller, you better learn to move your hands faster. That perfectly captures the essence of Moore's Law hitting its limits, right? We can't easily shrink the workbench anymore, so we have to fundamentally rethink how the work actually gets done.
If we look back, we can clearly see this golden age of geometric scaling, from its birth in the 1970s through the massive silicon boom of the 1990s. The global semiconductor industry totally thrived on this trajectory. But as we arrive in the 2020s, that trusty map has bumped into the hard, unforgiving walls of quantum physics and skyrocketing manufacturing costs.
So this brings us to a really pivotal moment. As Huawei's semiconductor president, He Tingbo pointed out at the 2026 IEEE ISCS symposium in Shanghai, the entire global industry is facing diminishing economic returns. The reliable old method of just making things smaller? It's simply no longer delivering the cost benefits it once did, and the industry is heavily constrained.
We really have to look objectively at this tension. It's not just the physics, right? It's the extreme difficulty and the astronomical cost of getting access to advanced EUV lithography tools. These are incredibly complex machines, needed to print the tiniest chips, and it's created a critical bottleneck in the global supply chain. This landscape urgently requires a paradigm shift. We have to find a new, sustainable evolutionary path to match the world's surging computing demands.
So what's the big game changer? It's a new metric called tau. In physics and engineering, tau represents the mathematical measure of time delay in signal propagation. Instead of obsessing over building tiny physical structures, the tau scaling law focuses on the speed of life within our chip city. It's all about finding every possible way to reduce the time it takes for a signal to race from point A to point B.
And Huawei didn't just slap this idea onto one part of the chip. Nope, they established a multi-level co-optimization mechanism. They're actively working to shorten the time constant, tau, from the microscopic underlying physical device level up through the circuits and chips all the way to massive system-level networks of machines. It's a total top-to-bottom rethink.
Zooming in to the circuit level, we hit this absolutely incredible core innovation they call LogicFolding. You see, traditional circuits have rigid physical boundaries. LogicFolding breaks those layouts down, significantly shortening the critical path wiring. By effectively reducing the resistive and capacitive load of signal propagation, they can boost transistor density and performance without even needing a more advanced lithography machine.
Think of it like a track relay race. The old strategy, Moore's Law, was basically trying to win by constantly breeding runners with shorter and shorter legs to fit more of them on the track. LogicFolding, however, is a completely new playbook. It lets the runners efficiently loop back, reusing the same physical track to carry more messages over time. It's all about efficiency of movement, not just physical size.
Now, if we zoom all the way out to the system level, they use a newly redefined interconnect protocol called UnifiedBus. When you have thousands of computers working on massive AI models, communication delay is absolutely your biggest enemy. UnifiedBus allows thousands of physical compute nodes to share memory and talk so seamlessly that they learn, think, and reason like one single giant logical server. To picture just how crucial this system-level connection is, imagine Colonel Debs, Papa's spouse, acting as the ultimate traffic conductor right in the center of our digital city. Kernel Debs is perfectly optimizing the routes, gently managing the flows, and timing the data packets so flawlessly that traffic jams are eliminated entirely. That level of brilliant coordination is exactly what UnifiedBus achieves for massive data centers.
This kind of brilliant traffic management comes to life rapidly in Huawei's new SuperPoD architecture. Built to handle the massive, hungry demands of trillion-parameter AI models, this lineup includes the liquid-cooled Atlas 950 for ultra-large-scale training, the air-cooled Atlas 850E for enterprise inference, and the Taishan 950, which delivers 100-nanosecond-level ultra-low latency for general-purpose computing.
And here is the kicker. This isn't just some theoretical whiteboard fantasy. Over the past 6 years, driven by pure necessity and relentless innovation, Huawei has actually designed and mass-produced 381 different chips based on the principles of the Tau scaling law. 381. And they're already serving a wide range of global industries.
In fact, we're going to see the consumer-facing results of this very soon. The new Kirin chips, scheduled to launch in the fall of 2026, will be the very first to adopt this LogicFolding architecture. By moving away from a pure reliance on geometric shrinking, they aim to considerably enhance real-world performance in everyday devices like the smartphones we all carry in our pockets.
But look, solving this massive semiconductor bottleneck is a monumental task. Like He Tingbo stated, Huawei totally acknowledges they can't rewrite this technological fairy tale alone. And that is exactly why they are opening access to the UnifiedBus protocol, making their UBOS software components open source, and opening up their SuperPoD hardware for global developers and partners to build upon.
So if we pull back and look at the big picture, let's synthesize a few critical takeaways from this explainer. First, the industry is navigating a fundamental shift from scaling physical space to scaling time. Second, innovations like LogicFolding and UnifiedBus are actually making this possible. Third, a really open ecosystem is being built around these SuperPods. And finally, using this Tau methodology, Huawei expects to yield a 1.4 nanometer equivalent transistor density in their high-end chips by 2031, without strictly relying on the next generation of lithography tools.
As we wrap up, I want to leave you with a final Papa-inspired thought. For decades, we've been completely obsessed with the static size of our microscopic cities. But perhaps true human ingenuity in the 21st century isn't just about conquering physical space. Perhaps it's about mastering the beautiful, fleeting efficiency of time itself. Thank you so much for joining me on this journey through the Tau scaling law. Keep questioning, keep learning, and I'll see you in the next explainer.